Imagine this. You're wrapping a gift, sealing a package, or fixing something that broke 5 minutes before a deadline. You reach for tape, press it down, and almost forget it's even there. It's clear, nearly invisible, quietly doing its job. But have you ever stopped to wonder how tape, something sticky by nature, became transparent in the first place? After all, stickiness usually means gooey, cloudy, or messy. So how did engineers manage to create something that holds things together while practically disappearing from sight? The answer takes us through chemistry, material science, wartime innovation, and a surprising amount of trial and error. Let's explore, right here, on History of Simple Things. To understand transparent tape, we need to rewind to a time before it existed. Early adhesive tapes were anything but clear. In the late 19th and early 20th centuries, tape was typically made from cloth, paper, or rubber-backed materials. These tapes were strong but bulky, opaque, and often ugly. They were designed for industrial use, binding, sealing crates, insulating wires, not for everyday household tasks. Visibility wasn't a concern. Function came first, and aesthetics didn't matter at all. The idea of a nearly invisible adhesive simply wasn't necessary yet. That changed as modern manufacturing and consumer products evolved. In the 1920s and 1930s, industries like packaging, printing, and retail began demanding cleaner, more precise solutions. Companies wanted labels that looked neat. Businesses wanted packaging that didn't distract from branding. And everyday consumers wanted something that didn't scream, "repair job." The push toward transparency wasn't about novelty. It was about subtlety. Tape needed to hold things together without drawing attention to itself. The breakthrough came from rethinking what tape was made of. Traditional tape relied on cloth fibers or paper backings, which naturally scattered light and appeared opaque. To make tape transparent, engineers needed a backing material that allowed light to pass through cleanly. This led to the use of cellophane, one of the earliest transparent films made from regenerated cellulose. Cellophane was smooth, flexible, and most importantly, clear. Originally developed for food packaging, it proved to be the perfect candidate for a new kind of tape. But creating clear tape wasn't as simple as slapping adhesive onto a transparent film. Early attempts failed because the glue itself ruined the effect. Most adhesives were cloudy or yellowish, blocking light and turning the tape hazy. Scientists had to develop a pressure-sensitive adhesive that was not only strong and flexible, but also optically clear. This required precise control over the size of adhesive particles. If the particles were too large or uneven, they would scatter light, making the tape visible. When they were engineered at just the right microscopic scale, the adhesive became effectively invisible to the human eye. Another challenge was durability. Transparent tape needed to stay clear over time. Exposure to air, heat, and sunlight can cause materials to yellow or degrade. Early clear tapes often aged poorly, becoming brittle or discolored. Chemists solved this by refining polymer formulas and adding stabilizers that resisted oxidation and ultraviolet light. Over time, transparent tape became not just clear when new, but clear for years. Interestingly, one of the biggest boosts to transparent tape came during the Great Depression. People couldn't afford to replace broken items, so they repaired everything: books, window shades, torn paper. even cracked currency. Clear tape was perfect for this. It fixed things without making them look worse. Its invisibility gave it an almost magical quality, as if objects healed themselves rather than being patched together. That everyday usefulness cemented transparent tape as a household staple. World War II pushed the technology even further. Wartime manufacturing demanded materials that were lightweight, strong, and versatile. Transparent films and advanced adhesives were developed rapidly for military use, and many of those innovations made their way into consumer products after the war. The tape benefited directly from advances in polymer science, leading to stronger adhesion, smoother films, and better clarity. So why does transparent tape look clear in the first place? The answer lies in how light interacts with materials. Objects appear opaque when they scatter or absorb light. Transparent tape is engineered so that both the backing film and the adhesive have similar refractive indices, meaning light passes through them at nearly the same speed. When light doesn't bend or scatter much at the boundary between materials, the tape becomes nearly invisible. It's not truly invisible, of course, but it's close enough that your brain ignores it. Modern transparent tapes are the result of decades of refinement. Today's versions use advanced plastic films like polypropylene or polyester, paired with acrylic-based adhesives that are crystal clear and long-lasting. These materials are precisely manufactured at the molecular level, ensuring consistency across millions of rolls. Even the slightest variation in thickness or chemistry could make the tape cloudy, so production is tightly controlled. So the next time you tear off a piece of clear tape, remember this: you're holding a small miracle of material science. A product born from industrial demands, refined through economic hardship and global conflict, and perfected through microscopic precision. Transparent tape didn't just happen. It was invented, tested, failed, improved, and optimized, until it could quietly disappear while holding the world together. And that might be the most impressive part of all. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.